Excel Tips. My name is Neale Blackwood, and in this episode we're going to look at how we can build a month and year-to-date report using dynamic arrays in Excel. Dynamic arrays are a new calculation engine within Excel, and they allow you to work with ranges in the same way that you used to work with cells. So we'll see how we do that as we go through the video. This is the second in a three-part series. So the first episode looked at how we can build a reforecasted full year report using dynamic arrays. We're using the same data set as we used from that, so you can check out the Neale Blackwood website to see the previous video. And the next video will be on how we can build a dashboard using dynamic arrays. You can download the companion file at the Neale Blackwood website. Note that you need the subscription version of Excel to use dynamic arrays. Also note this includes some reasonably advanced concepts, so you might need to watch the video a couple of times to get a good understanding of these dynamic array techniques. So I'll take you through the data that we're using here. So we've got a data set of the actuals that's got the date, which is really the month, the state, the department, account number, and also the amount. Thing to pick up here is that all of the revenue items are shown as a negative, so we need to handle that when we come to build our report. The budget data is a typical budget layout where we've got the accounts going down the column and the months of the year going across. I'm just hiding the middle ones here. And we've also got a table sheet here with all of the account numbers, their category, and also the sign. So this is how we're going to cope with the negative revenue and how we can convert that into a positive figure for our report. These two lists here are for the drop downs. We have the ability on the control sheet to select a previous month, and we've also got the ability on our report to select a state. Let's see how that works. The asterisk represents all states, and that'll be explained later in the video. The month of the year is determined by this formula here, where we're looking for the max value from the date column in the TBL GL data. Now, this is what's called a structured reference. It's basically a table name. So the actuals data is a formatted table, and it has a name. So if I click on table design here, you'll see it's called TBL GL data, and the name is used in conjunction with those square brackets to refer to a column within that table. The beauty of using a structured reference is that it automatically expands as data is added to the table, which we'll see at the end of the video when I update for February data, and we'll see that everything just automatically updates. Okay, so let's go and look at our budget data and see what we need to do to calculate our current month and our current year-to-date. The current month is surprisingly easy to extract from our data on the left-hand side. We've got a month number here which is coming from the control sheet. So we're in January 24, and so we are in the 7th month of this financial year. So we want the 7th column in the range, and so what we can do is we can refer to the whole range on the left hand side. So that's a two-dimensional range. Now this is part of the dynamic array functionality. So normally you'd select the row from D2 across to O2 and use the index function, but with dynamic arrays you can refer to the two-dimensional range. So that's the range you want to extract from. The second argument is the row number. Now we don't want a particular row number. We want to extract the whole column from the range, and so we're not going to define a row number. We're going to define the column. And so what this does is this gives us the 7th column from that two-dimensional range, which is what we want. We want all of the numbers in the 7th column, which would be January. And so this structure gives us that. So it's leaving that blank allows us to then say we want the 7th column. And so the index function, so if I open this up, You can see we want January, and you can see the current month is being extracted in column R. The current year to date is a little bit more complicated because we need to create a range that moves across the page as the year progresses. So that is more complex, and in that case we're going to use the offset function. So let's see how this works. Ignore the BYROW function, I'll explain that later. The offset function is a little bit similar to the index function. What it does is it's taking the first column in that range, so from D2 down to D175. It's then offsetting. Now, because we've got a 0 here, it's not actually moving, it's not offsetting from that range. That's the number of rows to offset. That's the number of columns to offset. So by having 0, 0 there, it means we don't want to move that particular range. So we've still got D2 down to D175. And then similar to what we did with the index, where we don't have this height argument, that means that we want to refer to the whole column, if you like. And then lastly, we tell it how many columns to include. So this one here was the height, and because we didn't define the height, it uses the existing height, which is basically row 2 down to row 175. And then you tell it the width, which is how many columns in that range. And that is 7, which is in cell V1. So what this does, this creates a range that starts in column D and goes across to whatever column January is, because that's the 7th column in the range, or 7th columns away from it. It includes column D. Okay, so that's it's creating a range that's 7 columns wide from row 2 down to row 175. So the offset has created a 2-dimensional range that we need to work with. Now, there is a special function in Excel called BYROW, and so what that does is that chops up that range into rows. So it's basically saying by row, it's going to extract that row from 2-dimensional range, and then it needs to do something with it, and so you need to use the lambda function. So lambda function is a function that doesn't do any calculations, but it allows you to use variables. And so I'm just using the variable x here as a name. So the BYROW chops up that 2-dimensional range into rows, and each row is given to the lambda function as this variable x. And once you've got that variable, you can then do a calculation. So in this case, it's a very simple one. We're just going to sum the x. So it's going to sum up that row, and it's going to spill down. And that's something I should have mentioned in terms of terminology, is spilling, because the formula in column R spilled down to return the column. And that's the spilling is a terminology used with dynamic arrays. And so this sum formula is going to spill down as well. And so each of the rows has been added up. So with spilling, the formula spills down the column. The formula is only, in this case, in cell R2 or S2. And anything else underneath that will break the formula. So if I type in, so this cell has 500 in it. If I type in 500 and hit enter, look what happens. It breaks the formula and displays the spill error. It needs empty cells underneath to populate with the values. As soon as I delete it, it's okay. Something to pick up, if you use the if error function, if error doesn't handle a spill error. Okay, you'll still have a spill error. Spill errors must be resolved, otherwise they can flow through to the rest of the file. So you need blank rows in whatever direction it's spilling. So at the moment we're spilling down. Some formulas might spill across, and they can also spill in 2 dimensions, so just be aware of that. So I've got rid of those lines within there, so hopefully you can see this blue line that goes all the way down to the bottom of our budget, and that's the spill range. So even if I put 1,000 here, even though it's the same value, that will break the spill range. Okay, and again, it's as simple as deleting it to reinstate it. So you must resolve any spill errors so that they don't flow through into your report. So that's how you create a sum function that spills down. So we needed this range to sort of expand as the year progresses. So that's why we've used the offset function. So when I drop in February's figures at the end of the session, this is going to actually expand out to include February as well. So offset's a really powerful formula. Offset had a bad name because it's what's called volatile, which sounds dangerous. But basically volatile means that the formula calculates every time Excel calculates, which can slow Excel down. But with today's fast computers, offset isn't really an issue. And in this case, it gives us the flexibility to create a range that automatically expands across the page. Okay, so with those two columns created, we can now build our report. These formulas use range names. Now, I use range names in conjunction with formatted tables to make the formulas shorter. So I'll just show you what I'm talking about. When you're referring to a structured reference, you need to include the table name and the column name in square brackets. Now, unfortunately, whilst that's really flexible, it does tend to make the formulas longer. And as a rule, the longer the formula is, the harder it is to read. In an effort to shorten the formulas, so I've used range names to refer to the columns in the tables. And so this creates shorter formulas, but they're still using the table names. So if we go back to here, what this formula does, so this is using two functions together. So the first function is called the filter function. Now what this is doing, it's looking in the account number column of the account table, and it's filtering by when the category column equals A6, which in this case is revenue. So that gives us a listing. So I can just do that. So if I get rid of the sort function, this is just going to filter. It's going to give us exactly the same result. The reason I put the sort in there was someone may add another revenue item to the bottom of the table, and having the sort function in there gets it in the right sequence. So that's the filter. So it's filtering a table and returning the results. So that's a really powerful feature. It's sort of like a VLOOKUP or an XLOOKUP. It's returning multiple accounts that equal the revenue category. I'll put the sort back on there, and all it does is that sorts the account numbers in ascending order. Now, having listed our account numbers for the revenue category, we can then extract the sign using XLOOKUP. Something that we haven't looked at yet is how you refer to a spill range. So we've created spill ranges, but we haven't referred to them yet. So to refer to a spill range, you need to refer to the top left cell and then follow that reference with the hash symbol. And when you do that, the formula you're using that in can spill to match that range. So in this case, we're using the XLOOKUP function, which is the replacement for VLOOKUP. So XLOOKUP can look up vertically and horizontally, and it's a lot more flexible than VLOOKUP. So we're saying look up the code in C7. You look it up in the account number range name. So ACC is the prefix for the account number table, and return the sign column. And if you can't find it, return a blank cell. So the XLOOKUP has a built-in error handler called if not found as the fourth argument. So I'll just show you the range name. So if we press the F3 key, function key, we can go paste list. And so these are all of the range names in the file. So TBL accounts is this table on the left hand side, and each of these range names is referring to a column within that table, but you can see the difference in the length of the name. If you use this structured reference, you're increasing the length of the formula, basically. By using range names, you still keep the description and it's still descriptive, but it's just a shorter formula that you're creating. So it has the advantage of referring to the formatted table, which automatically expands, which is really useful, and the added advantage of being able to have a shorter formula instead of having to use these longer structured references. Okay, so that gives us all of the signs for those account numbers, and this formula here is pretty much the same one, except it's returning the description column. So we get the description of our account code. Okay, the next one across, we're extracting from our actuals. So the actuals have the ACT prefix on the range names. So that's also a formatted table that's in the GL data sheet. So we're looking in the actual amount and we're going to add up the amounts there. So we've got 3 separate conditions in this SUMIFS. So the amount column is only added up when the state matches, in this case, the asterisk. So in this case, it actually adds up all of the states. When the date equals E2, and when in the account column, that equals, in this case, 3100. And at the end of this, we have the calculation to adjust for the sign. So what we've got here is times B7 hash. And so that's the -1 or 1 that we have in our column B here. And that converts the credit or negative revenue value in our GL into a positive value for our report. And there we have it. And that spills down. The reason it spills down is because we referred to the hash for the account number and the hash for the sign, which spills down. The budget is very similar. Now this, the BUD prefix, all of the names in the budget sheet have a prefix of BUD, and these refer to the budget, those columns within the budget. Month is the current month column that we populated when the state equals D3 and when the account equals C7, and again we're using the hash symbol, so that spills down. The variance, this variance calculation is interesting in that it doesn't use an if function. One of the problems with variances is that revenue variances are different to cost variances, in that when the value of actuals is above budget in a revenue item, that's a good thing. But when it's above budget in a cost item, that's a bad thing. And so usually you use an if function to determine which type of variance you're going to use. But we have this sign column, which allows us to calculate the variance fairly easily. So what we do here is we subtract the actuals from the budget and then multiply that by the sign. And that works out the correct variance. So in this case, we've got an unfavorable variance, so it's a minus, because revenue is below budget. Here we can see that we've got sales, other sales are slightly above budget, and we've got a positive variance. And so that formula there, in combination with that sign, actually creates a single formula that will calculate the variance for both revenue and costs. So, and that one just spills down. The variance percent is using an if function. So if the budget is 0, which could be possible, then we're going to display a 0. That avoids the divide by 0 error displaying. Otherwise, we're going to divide the value in column G, which is the variance, by the absolute of column F, so the budget. The ABS function in Excel removes minus signs. ABS stands for absolute. It's a mathematical concept. It's basically the distance from 0, and so it has the effect of removing minus signs. So minus 1000 is 1000. So it just removes minus signs. So the ABS function gives us a base that's always positive. Now the reason we do that is because sometimes you might have negatives in a cost. It could be the work in progress movement. That could be a negative. That can throw out your variance percentage calculation. So that's why I've put the ABS around the base that we're dividing by. That was the calculation for the month. So we're getting the current month actuals, current month budget, and then working out the variance. Let's look at year to date. Year to date is a little trickier because we need to work with a date range. The data that we had in our GL data actually has multiple years in there. So we need to work out the dates for the financial years, which is in cell E1 and E2. And so we can add up the amount column when the state equals D3. So that's the same as we had before, but we need two different conditions for our date. So it's got to be greater than and equal to July 23, which is the start of the financial year, and less than or equal to the current month. Those two conditions give us the current financial year, and then the account number obviously has to be the same, and also we use our sign. So there's an extra condition on the date column to make sure we get the financial year. It's not a problem in our budget because our budget is just one financial year. So this is pretty much the same formula as we had in the other budget column, but we're adding up the budget year-to-date column instead of the budget month column. Variance, same calculation. Variance percent, same calculation. And funnily enough, the actuals over here are the same calculation, but they're using the January 23 here. So it's the same calculation, but it's just using the previous year's month. So January 23 instead of January 24. The variance is same calculation as is the variance percent. And then the actuals, again, this is the actuals from the previous year. So it's using these two financial year dates for the year to date. So same calculation, just using different dates. And again, the variance is the same. We're comparing the variance with the year to date to the variance with the year to date from this year. And again, the variance calculation is the same. So a lot of the formulas are very similar in that row. And that formula has been copied down to rows 19 and 40. Now the thing to pick up here is that I have included extra rows to allow for the expansion if we do include another count number. So for example, for revenue, I could go into our tables here and go to the bottom. So what do we got? We got 3900. So let's create 3999 and I'll just call it miscellaneous revenue. So it's going to be a revenue code, and obviously it needs to be a -1. So that's right down the bottom of the table. If we go back to our report now, that miscellaneous revenue will be listed in the report. Now there's no actuals and there's no budget, but if there was, that would get picked up. So you can see it's very dynamic. It's just adding the account to the table will add it to the report. Now, the thing to pick up there is obviously if I added 10 new account numbers there, that would be too long for the range that I had and we'd get a spill error. But it's as simple as inserting a row. So if I insert a row here, just Control and the plus sign, that is a simple solution to any expanding ranges there. So I'm just going to undo that because I'll keep the references the same as the article. So that is the row 7. So that's doing all the hard work, and we just copy it down to the other sections. Now, if you did want to hide this section, you could select those and use Shift, Alt, and the right arrow. And that creates what's called grouping, which I've used here. And so you could then hide those rows. And then, so if you want to print it, we've got some grouping already in existence here. So if I click on 1 and 1, this is what the report would look like initially. And then you could maybe expand out using these plus signs to show the detail. And that's called grouping in Excel. I highly recommend you use that rather than hide and unhide, because you have buttons on there that make it a lot easier to do the hiding and unhiding. So plus means open it up, and minus means to close it. And that gives you some options for hiding and unhiding. And again, it's Shift, Alt, and the right arrow to apply grouping. And you can even use this Shift, Alt, and the left arrow to remove the grouping, as I've just done. Okay, now I'll just a quick explanation on how the state works. The state is in cell D3. When you use the asterisk symbol, that represents all codes, even blank cells. So it's a really easy way to add up everything and still have the ability to add up the individual items. I can add up by state, which I've got here as WA, or when you use the wildcard character of the asterisk, that includes all states. It only works with text codes. Unfortunately, it doesn't work with numeric codes. It only works with text codes. So the state column is all text. It's not numeric. So just a heads up there. The other grey cells here are representing the sums. And as you can see, the sum function is very easy in this case. All it's doing is using the hash symbol to refer to the range, and that's just adding those up. The calculation here is pretty much the same as we had above, but it doesn't use the hash symbols because it's only working on a single row. So that's, if you like, a normal Excel calculation there. And all these other formulas are pretty much the same. So that the summing part is very simple here. As this spills down, this will include that spill range. Okay, so I've covered a lot of different techniques here. You might need to go through the video a couple of times to get your head around some of these concepts because they are reasonably advanced, but it does sort of showcase how powerful these dynamic array formulas can be when you use them together, because as you see, I've combined a number of functions to provide this functionality and flexibility. So we'll finish off by showing you how flexible this is. So at the moment we've got our January report, so let's open these up. So if we press those, we've got some extra data at the bottom of our table here. So this is our February data, so I'm going to copy that, paste that at the bottom of our table. Notice the table expands to include the new data. And let's go look at our report. There we go, February. So this is updated for February automatically. So all you need to do is drop in that February extra data and the report will automatically update. You don't need to change anything. So that's the flexibility of using these type of formulas. Hope you found that useful. Thanks for watching.